Hi, my name is Alex Williams, founder of the New Stack, and you are listening to the New Stack Analyst Podcast. Each week, we look at application development and management at scale. I'd like to thank our sponsor today, the Intel Data Center Group, a leader in defining the open data center, cloud computing, and world of connected systems infrastructure. Its portfolio supports multiple processor families to offer options for workloads that reflect today's diverse user needs. That's the Intel Data Center Group. You can find them at intel.com. Now let's get to the show.
Well, hello, everybody. Welcome to day 2 of the Tectonic Summit, and welcome to the New Stack Pancake Breakfast. We would, well, first of all, we have our guest come on up and have a seat. Yeah. The idea of the Pancake Breakfast is to do some carb loading. This will be another day where we got a lot of information to process, and pancakes will get you ready for all the information that's coming up today. We'd like to thank Intel. Intel actually is sponsoring the podcast and the breakfast. They want to encourage conversation about containers and the container ecosystem. Right, fantastic. When I talked to Alex, the head of CoreOS, about this conference, he said that they wanted to hold it in New York specifically because they wanted to get the conversation out of Silicon Valley a bit. Let's talk a little bit less. I mean, there's a lot of interesting things about Kubernetes and microservices and containers, but let's bring it to the enterprise. What is the value proposition for the media companies and the financial service companies and the Fortune 500, basically? So what still needs to be done to incorporate Kubernetes into the enterprise? Yesterday, Craig McLuckie of Google had talked about why microservices-based architecture was pretty much inevitable for any web-scale companies. But I'm thinking about maybe the smaller company, the mid-size beverage distribution company that they may have some Lotus Notes apps, they might have a few mobile apps on AWS, maybe a Skunkworks project in terms of IoT, putting some instruments on the soda machines. I don't know, but how do you bring this together? How do you get from what they're doing to the green fields of a container-based ecosystem? I have a few questions that I want to ask the panelists. Well, I'm kind of a lazy sod, so I'm hoping that we'll get your questions. You've come back for day 2. I want to find out what questions you still have in terms of connecting the dots. How will Kubernetes and the container-based ecosystem work for you? What information do you still need? So first of all, let me have the panelists introduce themselves.
Sure, happy to go first. I'm Matthew Brender. I work at Intel as a developer advocate focused on software-defined infrastructure.
I'm Gabriel Monroy, the CTO at Engineered and Deis.
And I'm Alex Polvi, the founder and CEO of CoreOS. And first, I wanted to also say, special treat for you guys, coming so early, or not early, but coming to the very beginning of the conference today. We are going to make this panel as controversial as we possibly can for you. So get ready with your questions. It's your special treat for joining us in the underground here this morning.
And my goal is to not get fired.
Excellent. Well, let me throw out the first question then. What is it with Kubernetes? What still needs to be done to bring it to the enterprise? What do the enterprises need to do to prepare for Kubernetes? And in turn, what does Kubernetes have that the enterprise can latch onto?
Well, let me start by saying it's better than Docker Swarm.
Oh, wow. Here we go. We're off already.
Give the crowd with him one. No, I think that's an interesting question. I'll jump in since I had the first bad joke. We're talking actually with a lot of companies in the New York area, and I think there's a couple challenges. The first is to look at why you think about Kubernetes at all, and the Borg paper actually does a pretty good job of outlining why Google built Borg, and they outline in the beginning of the paper three real reasons. The first is what amounts to developer self-service, sort of going after the agility benefits. The second is extreme reliability. Faults in the infrastructure layer should not result in faults for deployed applications and the SLAs for those applications. And the third is the ability to scale out horizontally. That becomes really important for a company the size of Google. Turns out those same things are important for any business, including the mid-sized business. And so, making sure that folks understand that cluster managers can provide that value is, I think we're already seeing that, start to happen. In terms of some of the things that are needed for adoption, I think that there's a pretty general POC cycle that follows most technology trends. And one of the things that we see as kind of I don't know if it's a blocker at this point, but Kubernetes and cluster managers like it, Mesos and others, are actually modeled around declarative infrastructure. So you sort of define manifests, you submit those manifests to the cluster manager, and it ensures that stuff's running. That's great. That's actually the way the stuff should work. That's not how developers think. And so what ends up happening is you have this impedance mismatch between what the developers want to do in terms of thinking imperatively versus what the cluster manager wants, which is a set of manifests that are kind of awkward to write for most folks. And so we're focusing at Deis on tooling like Helm, which is a package manager for Kubernetes, and Deis itself, which is best thought of as like an imperative experience to drive Kubernetes using a Heroku-style workflow. So those are some things we're working on to push adoption.
Alex, this is your core audience. Yeah, what?
Sure. Yeah. So I think the bulk of the shell of the technology is in place today itself. There's still definitely kinks to work out, more features to add, give it better scale, make it work better. But I think there's one thing all enterprise IT departments share a big need for, and that's time. Needing time to adopt these technologies and to evaluate them. And I think that fortunately, we're at a point now where the technology is in a place that it is usable. You can start doing your POCs, you can start doing it, but the adoption curve of new platforms within the enterprise will just take a little bit of time. It's not something that happens overnight. You don't swap out your whole corporate infrastructure for a new platform quickly.
So do you start a test project or?
Definitely, and that's where things are at today. We're seeing it in enterprise R&D groups, are picking this up and playing with it. We're seeing it in new projects. Having I have to deliver my new platform by the end of the year, so that means I need to just pick a bet and go with it, and those sorts of things. But what we're not seeing, and this is shared amongst all things in the space, are a company, large enterprise company, saying, nobody yesterday, Goldman was not up there saying, we've retooled our whole platform on top of containers and distributed systems. We have no more VMware, we have no more Red Hat, we have no more legacy IT, and that, to get to that point, it's going to take time.
Excellent. Wow. Matthew, we were talking about the culture before, the DevOps culture. One interesting thing, we have the New Stack's data scientist is in the audience, and he had found that people were starting to identify themselves as DevOps, not just developers or not just system administrators or operators, but there's a core group of people out there who they're putting on the resume, I am a DevOps. So DevOps is not merely a process. For a lot of people, or for some people, and for some people hiring, DevOps is now a job description. And when you start to think about DevOps, what changes when you start to think about the DevOps kind of style? It must have some changes on the corporate or the work culture itself. And you were thinking about that as well.
Yeah, I'm fascinated by the way technology is, in fact, affecting the way the team cultures actually lay out. And then this idea of DevOps is truly a cultural change that is both tooling and changes in the way the organization communicates with each other. But then when you start mapping that to what's happening technology-wise, like you have to actually think about the languages in which people are communicating, and checking in infrastructure as software to a centralized repository is incredibly empowering to everyone there. I also think it's fascinating package managers for Kubernetes. Kubernetes is fundamentally infrastructure, but it's infrastructure as code, and it's crucial that both sides of operations and the application developers are comfortable with understanding what they need to control and what they can't.
Excellent. So my colleague Benjamin Ball is out there with the microphone. If anybody has any questions.
Yeah, I'm going to come around here, and if anyone has any questions, just kind of wave at me, and we'll see if you can pose it to the panel. Lawrence has got a question. I'm going to go over to him real quick. Lawrence is our, as Joab mentioned, data scientist at NewsTag, and so he's full of questions.
I don't know if I'm really a data scientist. I just like data. What open source projects are going to fall away and not be usable anymore if people keep on using Kubernetes and other tools? For example, what's going to happen to Mesos?
Well, there's your opening for controversy, Alex.
For the most difficult parts of open source, which I would characterize these distributed systems clusters as in that class of difficult parts of open source, other things in that class are kernels and virtualization and these other gnarlier things of open source. What we typically see happen is one major project move out front of all the rest, and then a set of other ones that are very well technically sophisticated and interesting, but have minor market share. An example of this is Linux versus the set of other open source operating systems out there, the BSDs, Solarises, and so on. And I think we'll see a similar thing happen at the cluster management level.
Names?
I think Kubernetes will be the one that is the one to take the hat.
But getting back to the enterprise readiness, I think there are a few elements of enterprise technology that I don't see readily available in the Kubernetes community, and it's something that I really hope that we can all, as a collective, fix. One of which is some of the scaffolding in between. Like, we heard some stories yesterday of people that are just starting out, and then people that have reasonably mature, mid-sized to larger infrastructures. And there are a lot of segments along the way, and some frustrations along the way and lessons learned that I think aren't easily found, and that there's a lot of room to share.
Yeah, I definitely agree with that. Just like when Linux emerged, to just continue, there's an open source question, and when Linux emerged, you need a Red Hat in order to prepare it for the enterprise. You need a distribution that's ready for businesses to make it useful to them. And I think the exact same thing will happen on this distributed systems layer at the data center as the whole computer level, and that's what we're trying to do with Tectonic fundamentally at the end of the day.
And I think with regard to Mesos, it's a subtle distinction, but an important one. Mesos is actually a scheduling system primarily, whereas Kubernetes is actually focused on a real cluster manager. And if you're familiar with these systems, scheduling is actually an important but still relatively small part of the overall problem. How you actually wire up the different services in the platform, how you manage these things via loose coupling over time, those are problems that Mesos doesn't solve, not directly. They're solved via third-party frameworks typically. But one of the things that Mesos did a great job with is actually shipping frameworks that provided a lot of business value, and I think that's one of the reasons why you've seen Mesos kind of off to a really racing start. But what I'm already starting to see signs of is that the scheduler framework model is a little bit awkward to work on when it comes to the type of applications that most of the companies we interact with want to see. If you're doing batch analytics, and that's, you want just a scale-out cluster, they offer great stuff. But if you're looking more for microservice style architectures and something that's going to kind of grow with you over the next 12 to 18 months, I think that's really where Kubernetes fits.
Excellent. Any other questions out there?
Yeah, I think we got one.
All right.
Hi, there was a lot of concern in various talks. People have always said it's all great, but it's security. And there's stuff built in, obviously, in the kernel and Docker containers and use it, but people believe it isn't enough. So are we going to have the case where, what do you think about security, and are we going to have a case where we run ahead with the functionality, and then we're left for 10 years trying to hack back security?
Someplace would easily be controversial.
So I think it's important to think about security in a couple dimensions. The two important ones are runtime security, which is I think what most people consider first, and then the other is network security. Runtime security is, it's funny. There was a big long Twitter discussion between a number of folks and about container versus VM security, and a lot of people just kind of take on faith that the hypervisor and VMs are sort of more secure, and the reality is that there's a ton of CVEs and problems with the hypervisor layer. The sort of shared containerization approach does have this shared syscall surface that is more dangerous on its head than a VM, but it's not necessarily true that one is necessarily better than the other in terms of runtime security. I think the bigger problem is actually network security, and specifically policy-driven network security. Right now, state-of-the-art in container architectures is everything to talk to everything else on like a flat overlay network. I mean, every Mesos deployment I see, every Kubernetes deployment I see, that's what it looks like. And if you take that and you put that in next to an Amazon instance-based, where you have security groups controlling ingress and egress, it pales in comparison that the network security story does. And that needs to be fixed, and it needs to be fixed really soon. I think the good news is all this stuff, people are aware of it. There are solutions in the works for these things. Folks like Project Calico have terrific policy-based solutions that work in the constructs of declarative infrastructure and Kubernetes specifically. So that's really what I'm looking forward to. I think I'm less concerned about the runtime security at this point than I am about the network security.
I also think culturally we need to stop thinking of security as a feature. That it's a collection of elements and practices all throughout the stack. Certainly it's serving as Intel to think about it that security starts with your hardware and works all the way up to container and across containers. And we have to start thinking about how all these layers interact.
Now let's take a quick break before we get back to the second half of the show. I'd like to thank the Intel Data Center Group, a leader in defining the open data center, cloud computing, and world of connected systems infrastructure. Its portfolio supports multiple processor families to offer options for workloads that reflect today's diverse user needs. That's Intel Data Center Group. You can find them at intel.com. Now let's get back to the show.
I think about security is, when containers came about, what did we degrade? What did we get a more degraded security experience? And then what did we get a more enhanced security experience around? And the initial implementations of containers, namely around Docker, are around building an image and sharing that image and running that image. So it's effectively a replacement for an RPM or a DEB. So when we look at the security models of RPM and DEB versus the security model of Docker, from that perspective of just what we have in the market, it was a slight degradation. There was some issues around signature validation and things like this, just basic table stakes of package management that are kind of overlooked and just now getting resolved. And I think it's these just little table stakes issues which has actually given this very bad security rap to the container thing overall. It's like an unfortunate implementation of these practices. Where are we seeing advancements? Well, before containers, you had these servers that you were running multiple applications on. You probably didn't run just one server per application unless you had some workload that was extremely intense. And in that case, if you have one server that has many applications running on it, if any of those applications are compromised, well, now you have access to that whole host. And while containerization isn't a perfect layer of security, it is another wall. It's another boundary. It's like the walls in this room. They're not perfect security mechanisms, but they do prevent things from coming through. And so I think in that case, containers are actually a step forward for most companies. And the only place where it's a degradation to use a container is if you were previously running one application per virtual machine. And there's nothing preventing you from doing that today with containers either, if you already had that architecture. So I actually think that the containers create a operational model that allow us to make things more secure than they previously were before, and we've gotten a very bad rap up to this point because of some unfortunate implementation details.
All right, terrific. Questions? Oh, I got a question. I would like to ask the lock-in question. When virtual machines, the big promise was that they eliminated the lock-in from the specific hardware, and one of Docker's advantages was the fact that you didn't get locked into a particular cloud player. But what is the lock-in with Kubernetes, and what are some of the ways that it allows the enterprise to remain independent?
So lock-in occurs when your people or programs interact with a proprietary API. Okay, and that let's say the reason Amazon EC2 is so popular is because there's a control plane API, which is proprietary, but the way you consume the resources is over an open API known as SSH. That's an open protocol, an API, into managing that resource. Okay. In the Kubernetes world, and I think one of the reasons we're going to see hybrid and all of these things is because we have an API that's fundamentally open. It can be implemented in many different ways on the back end, and it really doesn't matter, but if you conform your applications to those APIs, and your operators know how to use those APIs, that's how you avoid lock-in. So anywhere where you talk a API, and I think of APIs as like SSH or MySQL or Kubernetes web-based REST APIs, kind of all of that are APIs. Anywhere where your applications or people are interacting with that needs to have an open source implementation. It needs to have a MySQL, even though on AWS Aurora is this crazy proprietary thing that they built. That's okay. But when you get into like DynamoDB and these other things that you only have an API that's implemented by a proprietary implementation, then that's where lock-in happens.
Yeah, I think one of the things we find talking to customers is that portability of their infrastructure and their workloads is incredibly important, even if they don't choose to exercise it. Right? It's sort of like an insurance policy that needs to be taken out. People need to make sure that if for some reason they need to move clusters on-premise for compliance, or if they need to spin up an operation in Europe and safe harbor is getting in the way, they need the ability to have something like open APIs in a way that they can control them. I personally am a big fan of Amazon. But the services that don't have an open source analog, DynamoDB, or I don't know, pick your Amazon service, a Lambda or something like that. The way I sort of think of it is every time someone inside of an IT organization chooses to use one of these lock-in services, like there's like a freedom kitty somewhere that dies. It's just really sad, and I actually view it as our sort of responsibility in sort of the cluster manager ecosystem to make sure that we can provide suitable alternatives that provide the equivalent functionality, but running on top of the cluster manager. And I think the way that'll manifest is sort of the suite of AWS star AAS services actually running atop the cluster manager, proven to scale and with the same availability.
All right, terrific. Well, we still got a few minutes left before the keynote starts. Oh, Lawrence has a question.
Following up on lock-in, I found that a lot of the lock-in has to do with infrastructure, people having relationships with a cloud provider like Amazon or Microsoft, Google Compute Engine. What are you guys doing to make sure that Kubernetes and your project is going to work on those platforms and that they're actually going to help collaborate and not compete with you later on?
I'm of the opinion that it's important to get features into the cluster manager, and as a community, try and things that we do in Deis, for example, that can be done at the cluster manager layer better. I'm a fan of doing that, right? Because we're at the end of the day interested in driving business value. One of the things I will say, to make this a little controversial, is I'm personally, every time I see Kubernetes, for example, introducing features that leverage cloud provider APIs, I get sad because, because there's a lot of folks out there who are interested in running this on bare metal or possibly running this on bare metal. And though it's really cool that you can spin up a load balancer and have it, automatically create ELBs or the equivalent on GCP, that is not working with the lowest common denominator feature set that is the reality in the enterprise today. So, I prefer, if we're interested in making Kubernetes really, truly a lock-in prevention layer and set of open APIs, every time we add a cloud provider integration, we're harming that effort, in my view.
I think any meaningful area of new business and infrastructure that cloud providers will provide. So if AWS sees that Kubernetes is getting traction, they will offer an AWS or Kubernetes as a service.
Right.
Like it'll happen. You have to assume it'll happen. And so then it's like in fact, Amazon has time and time again used like the startup space and all this stuff as a test bed to see where the next set of product development should come from. I think there's no exception here. And so as somebody building a product in this space, how do you compete with that? How do you compete with Amazon? Amazon's everyone's worst nightmare, from startups to VMware to Oracle, like everybody. And you have to do things that they cannot do. And that's why you see a lot of these vendors in the data center. That's why you see a lot of these vendors promoting cross-cloud options and things like that. These are things that like Amazon is physically incapacitated to doing. And so you have to find that differentiation, because Amazon and the other cloud providers will get into this business if customers want it, if their customers want it at the end of the day. And that's what they should be doing as well.
Yeah, and to the point of how Deis actually finds ways to contribute back to schedulers and orchestration engines and then focus on how they differentiate. I feel like that's a very parallel story to what we're up to at Intel when it comes to we know that we're selling you hardware, and we want you to buy more of it. That would be ideal. And what we can do is provide a common language to consume your telemetry from that with the framework Snap that we released yesterday. So it's about standardization of things and giving away whatever you're not planning to monetize. That's actually how you improve the ecosystem and flatten it out.
And Snap's not just an Intel only thing. You said that
absolutely not.
AMD can make use of it as well.
Yeah, it's designed to be an extensible architecture that we came out with some plugins that for collecting statistics from our own hardware that we know very well, but you're welcome to extend that on any and all platforms, and we'd love for it to be a collective catalog. End of sales pitch but it's open source, so I'm not selling.
All right, terrific questions. We got these guys in the hot seat. Yeah, here we go.
The consensus view, I guess, from most of the people I've spoken to is that containers and microservices kind of go hand in hand, and they're often mentioned in the same breath, in the sense of, if you really want to make use of a cluster-managed container platform effectively and get the scale and these kind of things, you need to start to think about applications in a different way. And I'm a big fan of this kind of move. I think what it does imply, to me at least, though, is that it means that really legacy applications have no play, or you're not going to get a lot out of a container platform if you're trying to run legacy applications without changing them rather dramatically, which, of course, from an adoption perspective, is a much greater barrier to entry than we had with the virtualization adoption, whose big pitch was, you don't have to change anything, just put it on a VM, and more or less it'll work. So I can totally see the use case for new build applications, because you want to use the newest architecture and the newest runtime to match for it. But what will happen with legacy applications? Will they always have to stay off until they're re-architected, or back to the panel?
So, I think, first of all, that, I'm a big believer that containers are orthogonal to microservices, are orthogonal to distributed systems. And you really have to look at those as sort of separate items. One of the patterns, that we see with regard to legacy is there's actually a ton of value in taking a Chef or Puppet, script that's, deploying some, service or web app, and taking the host based service and wrapping that inside of a container. And just doing that, right? And don't microservice the whole thing, don't go the full distributed systems. Just get the isolation benefits that Alex was talking about. Like, there's a win there because down the road, you may be able to leverage that as an artifact. And more importantly, you're going to start getting the cultural changes and sort of the CI/CD infrastructure in place to allow you to build more sophisticated pipelines overall. And frankly, it's a good way to get started with this stuff because a lot of people don't want to just jump full on into the cluster manager space. So I see that as a great answer for legacy. And with containers, you can run any sort of userland environment, and you'd be surprised the kind of legacy you'd be able to support in a containerized
architecture. I think this is one of the large myths of containers. One of the memes that has come around because I don't know where it came from, but at the end of the day, this is a process running on a Linux box. What application that you ran on Linux did not work that way before containers? Nothing. And so we have a number of ISVs here at the conference that you might consider legacy enterprise applications that are, friends at CA just waved over there. And they're here because they are containerizing their applications because it actually gives them a lot of benefit in how they can manage and update and cluster their applications. So I just think that this one is one of the straight up myths of containers that we'll get over as soon as we start seeing it be deployed more.
Yeah, and to echo that, just beware of misappropriation. Distributed systems problem is, by definition, non-trivial. So as soon as you start breaking what, monolith is used as a dirty word, but as soon as you start breaking up that monolith, you introduce a new level of complexity to your application structure that you need to know and you need to understand from levels of specificity that you just didn't have to when it was all running in a single space. And there's no magic cure to infrastructure. There will be choice. There will be change. That's probably the only two things that we're guaranteed these days. So get ready for the ride. There won't be a single answer in the coming months, and if there is in the future, I'll probably change industries because I think part of the fun of it is that we're constantly changing and evolving.
Excellent. I think we should start to wrap up. We have the keynote coming up at 9 o'clock, but let's give a round of applause to our panelists. Thank you all for coming out.
That's it for this week's show. Thank you very much for joining us. I'd like to thank the Intel Data Center Group. They're a leader in defining the open data center, cloud computing, and world of connected systems infrastructure. Its portfolio supports multiple processor families to offer options for workloads that reflect today's diverse user needs. You can find them at intel.com. That's the Intel Data Center Group. Audio editing and sound design for the News Stack Analyst podcast is provided by Broken Hours. You can find them at brokenhours.com. Thanks again, and hope to see you back at the show. Bye-bye.